10,
CLS go for main engine start.
6, 5, 4, 3, 2, 1, and booster ignition liftoff of Space Shuttle Discovery, taking the space station to full power for full science.
Every civilization, from the first humans who gazed up at the night sky to the modern physicists peering through their telescopes, has asked the same question: how far can we go? It is the question that humbles, terrifies, and inspires. The moon was once unthinkable. Mars was once unreachable. But light, the very thing that carries the sun's warmth to our eyes, has always taunted humanity with its perfect constancy, a cosmic speed limit we cannot break. And yet, we dream. So before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here, and tell me in the comments where you are and what time it is right now. I always find it fascinating to see our little community scattered across the globe. Now, dim the lights. Maybe turn on a fan for that soft background hum. And let's ease into tonight's journey together. The ancients imagined wings that could carry them across the heavens. Icarus, with wax and feather, reached for the sun and fell. The story is a warning, but also a prophecy. Humanity has always wanted to defy its limitations. Stars have beckoned us for millennia, silent beacons reminding us that there is more beyond the horizon. And as we looked up, we measured, we calculated, and we began to understand that the universe is not merely vast. It is almost incomprehensible in its scale. It was not until the 20th century that we began to grasp the true nature of this cosmic speed limit. In 1905, Albert Einstein shook the foundations of physics with his theory of special relativity. Among its many revelations was the startling truth: the speed of light is absolute. Nothing in the universe, no matter, no ship, no human, can reach it. To do so would require infinite energy. Light is not merely fast, it is the ultimate pace at which reality unfolds. And yet, in that limitation, there is also possibility. Because relativity tells us something profound. Time and space are malleable. To an observer moving near the speed of light, distances shrink and time slows. A journey that seems impossible from Earth can become survivable for the traveler. And so, the dream of reaching the stars did not vanish. It transformed. It became not just a question of speed, but of perspective. Think of the earliest astronomers, who measured the night sky with nothing but their eyes and primitive instruments. They traced the wandering paths of planets, the rise and fall of stars, and for the first time, glimpsed the immensity of the cosmos. The stars they observed were already centuries old by the time their light reached Earth. To look at the sky was, in a way, to look back in time, and to realize that even the closest sun might be far enough that a human lifetime is but a blink compared to its journey. As centuries passed, the dream of leaving Earth shifted from myth to possibility. The telescope revealed moons around Jupiter, Saturn's rings, the craters of the moon. Rockets became our arrows to the heavens, and humans finally walked upon the lunar surface. Yet even as astronauts planted flags and raised human ambition beyond our planet, the stars remained distant. The speed of chemical rockets, limited by fuel and physics, reminded us that even the nearest star is an eternity away in human terms. It is in this context that the dream of light speed takes on its tragic grandeur. The faster we go, the closer we approach the ultimate limit, and yet, the harder reality presses back. Imagine a ship hurtling at 99.99999% of light speed. For the crew aboard, the journey to a neighboring star might take a few years. But for those left on Earth, decades pass. Centuries. Time stretches and warps. The dream of exploration is entangled with the inevitability of loss, of missing generations, of returning to a world forever changed. Throughout human history, this dream has always been paired with imagination, science fiction, from the pulpy novels of the early 20th century to the intricate visions of modern writers, gave form to our longing. Warp drives, wormholes, star lanes, they are all ways of asking the same eternal question. What does it mean to go further than anyone has gone before? To move faster than the imagination? To cross the void that separates thought from reality? And it is not just a matter of mechanics or propulsion. Traveling at the speed of light is also a philosophical journey. It forces us to confront our place in the universe. The farther we go, the smaller we seem. Our petty quarrels, our fleeting worries, the histories we cling to, all are dwarfed by the vast stretches of interstellar space. And yet, the human desire persists. We cannot stop looking up. We cannot stop imagining ourselves among the stars. Consider the irony. Light itself has already traveled farther than we can ever hope to follow. The photons streaming from distant galaxies have been on their journey for billions of years. They arrive here as a whisper of the past, a record of civilizations, events, and phenomena long gone. And here we are, asking how we might chase them, how we might join them in their eternal flight. The universe is a track for which the fastest thing is already ahead, and we are the runners who will never catch up. And yet, the dream is not impossible. It is transformed. Near light speed, time bends, distances contract. A lifetime aboard a relativistic vessel could see a traveler reach places that, from Earth, would take millennia to arrive at. It is not magic. It is mathematics. It is physics. It is the strange, paradoxical truth that to reach the stars, we do not need to outrun light. We need to understand time itself. This is where our story begins. Not with the ships, not with the engines, but with the dream itself. A dream that has spanned civilizations, endured myths and legends, and now stands at the brink of reality. The dream of lightspeed is more than a pursuit of velocity. It is a pursuit of understanding, a confrontation with the limits of existence, and an invitation to see the universe as it truly is. Because the truth is simple and terrifying. No matter how fast we go, no matter how advanced our technology, the universe is vast beyond comprehension. And yet, the very act of dreaming, of calculating, of imagining, of daring, brings us closer to touching that infinite void. The question is no longer simply how far can we go, it is what will we become when we try. And so, humanity looks up. From the earliest firelit temples to the control rooms of modern observatories, the gaze turns outward. The dream persists because it must. It persists because light is patient, and because the human mind refuses to accept the limits of its own imagination. To travel at light speed is to confront eternity, to chase photons across the cosmos, and to realize that, in the act of pursuit, we glimpse the very nature of what it means to be alive. This is the first step on a journey through space, through time, and through understanding. The stars are not just destinations, they are mirrors. They show us what we are, what we can become, and the infinite possibilities that exist when a species refuses to stay grounded. The dream of light speed is not just a dream of distance, it is a dream of perspective. It is the story of humanity reaching beyond itself, reaching beyond Earth, reaching for something that may forever lie just out of grasp. And yet, in that pursuit, we grow. In that pursuit, we learn. In that pursuit, we become a species capable of imagining the impossible and daring to take the first steps toward it. Every journey begins with a question. Every question begins with a dream. And in this case, the dream is as bright, as fast, and as enduring as light itself. Light is relentless. It moves with perfect constancy through the vacuum of space, unaffected by gravity, impervious to obstacles, indifferent to distance. And yet, it is not just fast. It is the universe's ultimate rule, the speed limit written into the very fabric of reality. To approach it is to confront physics at its most unforgiving. To exceed it is to challenge the cosmos itself. And this is why, for all our dreams of the stars, the physics of light speed remains an insurmountable wall. Einstein's theory of special relativity shattered the comfortable assumptions of classical physics. It replaced Newton's absolute space and time with a universe where time slows and lengths contract, where mass is not fixed and energy is not optional. From this revelation comes a sobering truth. As an object with mass accelerates toward the speed of light, its relativistic mass increases. The closer you get to C, the more massive you become. And mass, in turn, demands energy to move. The paradox is merciless. The faster you go, the more energy you require, until, at the speed of light, the energy needed becomes infinite. Infinity, the unreachable, the unconquerable, is written into the very equations of the cosmos. Consider this: a spacecraft with a mass of just 1 ton, accelerating toward 99.9% of light speed, requires energy comparable to the total output of humanity for centuries. And that is only for one small ship carrying a handful of passengers. To accelerate larger vessels, with life support, shielding, and the supplies of a generation, the energy requirements balloon exponentially. The universe is kind to photons. It is not kind to us. But there is more than mass to worry about. Time itself begins to bend. From the perspective of the traveler aboard a relativistic vessel, clocks on Earth tick ever faster, while their own instruments slow to a crawl. This is not metaphor, it is calculation. It is the ultimate betrayal of intuition. Years may pass for the crew, while centuries sweep by at home. A journey to a nearby star may feel like weeks, but by the time the ship returns, generations have lived and died. Light speed is not just a barrier of energy, it is a barrier of experience, a wall separating the traveler from their own past and future. And yet, relativity offers an odd consolation. Because lengths contract along the axis of travel, the distance between stars shrinks for the traveler. Proxima Centauri, 4 light-years away to an observer on Earth, may feel like a mere fraction of a year's journey aboard a near-light-speed ship. This is the paradox that has enthralled physicists and dreamers alike. You cannot reach the speed of light, yet you can come astonishingly close. And in doing so, the universe itself bends to your motion, allowing the impossible to feel achievable, at least for those who move with it. But the universe is relentless in other ways. Accelerating a spacecraft to such velocities is not just a matter of fuel. It is a matter of physics itself, punishing carelessness. Collisions with interstellar particles, invisible dust grains moving at relativistic speeds, release energy sufficient to obliterate entire ships. Every gram of matter becomes a bullet fired from the universe's ultimate cannon. Shielding against this requires mass, which in turn requires more energy to accelerate, in an infinite feedback loop of impossibility. To travel fast is to flirt with destruction. The speed of light is more than a number. It is a cosmic law, encoded in the equations that govern everything from the trajectory of planets to the expansion of galaxies. It tells us that cause and effect are inseparable, that information cannot travel faster than nature allows, and that time itself is not a backdrop, but a participant in the unfolding story of the universe. To challenge light is not a matter of building bigger rockets. It is a matter of rewriting reality, something that, as far as we know, no civilization can do. Even in thought experiments, the consequences are profound. Imagine a ship somehow reaching 99.9999% of light speed. For the crew, the journey to the nearest stars may take mere months, but the energy expenditure would be astronomical, the stresses on human biology intolerable, the slightest collision catastrophic. Light speed is not a distance to be covered. It is a test of our ingenuity, our patience, and our humility. Yet humans are not easily deterred. The very laws that make light speed impossible also inspire innovation. Concepts like the Alcubierre warp drive exploit the loopholes of general relativity, proposing that space itself can be contracted and expanded to allow faster than light travel without violating the local speed limit. Wormholes, those hypothetical tunnels through space-time, promise shortcuts across cosmic chasms. Even if these remain speculative, they represent the essence of human defiance, the determination to approach impossibility, to push the boundaries of understanding, to find paths where none seem to exist. And so, the physics of the impossible is not just an obstacle, it is a mirror. It reflects our limits, our creativity, and our desire to reach beyond them. It forces us to recognize that the universe is not a playground, but a teacher, stern, exacting, and indifferent to ambition. Every acceleration, every gamma factor, every relativistic calculation reminds us that to dream of light speed is to confront the universe in its purest, most uncompromising form. It is also a lesson in patience. The cosmos is vast, and motion is measured not in human lifetimes, but in the slow dance of stars and galaxies. Light speed, while the ultimate pace, is only a fraction of the distances we hope to cross. Even if energy and shielding were solved, even if acceleration were humanly tolerable, the scale of space itself would humble the most daring travelers. And perhaps that is the point. The dream of light speed is not merely about distance. It is about perspective. It is about understanding that the universe operates on scales far beyond human intuition, and that our ambition must rise to meet it. The impossible is not a wall to stop us. It is a horizon to approach, a challenge to confront, a reminder of what it means to be human. The physics of light speed tells us what we cannot do, but it also reveals what is possible when we think not just of speed, but of space, time, energy, and perspective. It is a teacher as much as it is a barrier. And so, as we peer into the cosmos, measuring photons that have traveled billions of years, calculating gamma factors and relativistic effects, and dreaming of stars that will never see our return, we are faced with a paradox. We cannot reach light, and yet, by approaching it, by understanding it, we travel farther than our ancestors could ever have imagined, not in kilometers, but in knowledge, in comprehension, and in the very essence of what it means to move through the universe. The physics of the impossible is not the end of the story. It is the threshold. It is where human imagination meets cosmic reality. And it is here, on this boundary, that the dream of light speed begins to take shape. Not as a machine or a ship, but as a vision of what we can understand, what we can endure, and how far the mind can travel when the body is constrained by the universe's immutable laws. To the human eye, the universe is vast and immutable. Stars glitter like distant lanterns, galaxies spin in silent majesty, and space stretches into infinity. But the universe has secrets that defy intuition, secrets hidden in the mathematics of relativity, secrets that twist time and space into shapes the mind struggles to grasp. One of these secrets is the paradox that every traveler at near light speed experiences. Distance is not absolute. Space contracts. The farther you aim to go, the closer it seems, if you are willing to move fast enough. Imagine a ship leaving Earth at 99.99% the speed of light, engines roaring silently through the vacuum. To an observer on Earth, Proxima Centauri lies 4 light-years away, a daunting journey measured in decades at conventional speeds. But for those aboard the ship, the universe bends. Lengths along the direction of motion shrink according to the Lorentz contraction. Distances that seemed immense now compress, like a map folded neatly into the traveler's hand. Proxima is no longer 4 light-years away. It feels like a journey of months. The paradox is beautiful and terrifying. Reality itself warps to accommodate motion. Time, too, becomes an instrument of distortion. While the ship's chronometers tick steadily, Earth's clocks rush ahead. To the crew, weeks may pass. To those left behind, years, decades, even centuries unfold. Parents age, cities rise and fall, civilizations transform, and the travelers return to a world almost unrecognizable. In this way, light speed, or near light, travel is not just a voyage through space, but through time itself. It is a confrontation with the relativity of existence, where the universe refuses to be measured in human terms. The implications are profound. A young crew might leave Earth and, from their perspective, reach distant stars within a single lifetime. But the return is a homecoming to ghosts, a reunion with history that has moved without them. The relativity paradox teaches us that speed is more than motion. It is a shift in perspective. Distance is subjective. Time is subjective. And the universe, in its impartiality, allows no exceptions. Even at sublight speeds, the paradox is unavoidable. Accelerate to 90% of light speed, and time aboard the ship slows by nearly half. Accelerate to 99%, and the slowing becomes dramatic. Accelerate to 99.9999%, and the crew experiences months where the universe experiences millennia. These are not hypothetical musings. These are calculations grounded in Einstein's equations, verified by particle accelerators and GPS satellites, manifesting every day in ways both subtle and profound. Time does not tick uniformly. Space does not stretch uniformly. To journey at near light speed is to enter a world where the very geometry of reality bows to motion. And yet, the paradox offers opportunity as much as it imposes constraint. With sufficient velocity, distances that once seemed infinite become traversable, at least from the traveler's perspective. Interstellar voyages that would otherwise span generations can, in principle, be completed within a human lifetime. The dream of reaching other stars is no longer purely abstract. It is mathematically achievable if one is willing to pay the price in energy, risk, and solitude. But the universe imposes cruel balances. While distances shrink for those in motion, the outside world continues without pause. Wars are fought, societies change, technologies evolve, and civilizations rise and fall. The traveler is suspended between two realities, one of compressed space, one of relentless, unyielding time. The relativity paradox does not merely alter physics, it alters existence itself. To move through the cosmos is to move along a temporal tightrope, forever separating perception from objective reality. Consider, for a moment, the psychological weight of such a journey. To leave Earth is to embrace isolation, not just in space, but in experience. The closer the ship approaches light speed, the more the traveler is removed from the world they know. They witness distant stars rushing by, observe planets contracting along the path of motion, feel the passage of time stretching and compressing in ways that defy ordinary comprehension. They are, in effect, living a life out of phase with everyone else, a life that moves in its own rhythm, set against a universe marching to a different clock. And yet, there is wonder in the paradox. The shortening of space reveals a universe not fixed, but dynamic, responsive, almost sentient in its geometry. It is a reminder that human intuition, forged on a planet spinning at 30 kilometers per second around an ordinary star, is inadequate to comprehend cosmic truth. The cosmos is vast, but it is flexible. It is impartial, but it is full of astonishing possibilities. It yields to mathematics, and through mathematics, to imagination. The relativity paradox also reframes what we consider distance and reach. For a traveler moving near light speed, entire star systems can be traversed in a single subjective year. Galaxies hundreds of thousands of light years apart can be crossed within decades aboard a sufficiently fast ship. Yet, from Earth, these voyages stretch across generations. The universe becomes a realm of perspective, where the concept of far is no longer universal, but deeply personal. This paradox has consequences not only for physics, but for human ambition, colonization, exploration, and the spread of humanity into the stars are shaped not just by engines and fuel, but by the fundamental structure of space-time. Even the boldest spacecraft are bounded by the relentless mathematics of relativity. We may dream of Andromeda, of the Virgo cluster, of distant cosmic filaments, but each journey carries a hidden cost. The traveler's perception of distance, time, and reality will never align with those left behind. Yet in this misalignment lies poetry. To traverse vast distances is also to transcend ordinary time, to witness the universe in ways impossible from the confines of Earth. A near light-speed journey is not merely transport. It is a lens into the structure of reality itself. Stars, nebula, and galaxies are no longer static points of light. They are rivers of motion, bending and contracting, stretching and compressing, revealing the deep interplay between space, time, and velocity. Ultimately, the relativity paradox teaches a lesson both practical and profound. The universe is not a backdrop for human ambition. It is an active participant, shaping experience, bending reality, and reminding us that even as we move faster, the cosmos moves faster still. Distance is a relative measure, time a personal currency, and the dream of light-speed travel is inseparable from the mind-bending truths of the universe itself. And so, the journey continues, not merely across space, but through the very fabric of existence. To reach the stars is to learn that the farther we go, the more the universe reshapes our understanding of what far truly means. It is a lesson that humbles, exhilarates, and inspires. A reminder that even in the impossibility of light-speed travel, the human spirit finds a way to measure, perceive, and dream beyond the ordinary. The paradox is not a wall, it is a window. Through it, we see a universe that is stranger, deeper, and more beautiful than imagination alone could ever convey. And it is through this window that humanity peers forward, daring to chart a path across light years while the cosmos bends, contracts, and stretches in ways only the boldest travelers can comprehend. To speak of light speed is to speak of distance, and to speak of distance is to confront the immensity of the cosmos in a way the human mind was never designed to comprehend. Even the nearest star beyond our sun is a chasm so vast that conventional intuition fails. Space is not a landscape. It is a canvas stretched beyond reckoning, a void so immense that light itself requires years, decades, and millennia to traverse it. And yet, we dream of crossing it. Start with the familiar. The moon, just 384,000 kilometers away, seems close when measured in human terms, a distance a modern rocket can cover in days. Mars, in its elliptical orbit, drifts between 55 million and 400 million kilometers from Earth, a journey of months for our fastest spacecraft. The solar system itself, the region dominated by our sun, stretches billions of kilometers in all directions. At these scales, even near light-speed travel might seem excessive, but these distances are merely the prelude, the prologue to a story that becomes almost incomprehensible as we move outward. Proxima Centauri, the nearest star beyond our sun, lies 4 light-years away. That is over 37 trillion kilometers. Even traveling at 99% the speed of light, the journey would take more than 4 years, decades in Earth's time, but only a fraction of that for the relativistic traveler. Beyond Proxima lies Alpha Centauri, Barnard's star, Wolf 359, and thousands of stars that form our stellar neighborhood. Each is a sun with its own planets, its own potential mysteries, yet even collectively, these stars are but a speck in the galaxy. The Milky Way, our galactic home, is a spiral of hundreds of billions of stars, stretching roughly 100,000 light-years across. To traverse it at light speed would take 100,000 years. That is longer than recorded human history. That is longer than the span of countless civilizations, wars, rises, and falls. And still, beyond the Milky Way lies Andromeda, 2.5 million light-years away, a galaxy so massive that even traveling at light speed, a journey there spans epochs. Beyond Andromeda, the universe is filled with clusters, filaments, voids, and superclusters, stretching billions of light-years, boundless in ways that defy imagination. To place this in perspective, consider this: the observable universe, the portion we can see, limited by the age of the cosmos and the speed of light, stretches approximately 46 billion light-years in every direction. That is not the edge of existence. It is merely the horizon of observation. Beyond that horizon, space continues, expanding faster than light can travel. Every galaxy we see is a record of the past, its light already ancient by the time it reaches us. To traverse it, to reach even a fraction of these realms, is to confront distances that dwarf human life and endurance. And yet, there is a paradoxical intimacy in this vastness. Light speed may be a cosmic speed limit, but relativity tells us that motion contracts distance for the traveler. While earthbound observers measure journeys in thousands or millions of years, the traveler experiences a compressed universe. The distance from here to Proxima, once insurmountable, can shrink into months or weeks. The stars themselves bend to the motion of those brave enough to move near light speed. The immensity of space is not a fixed obstacle, it is a canvas that warps with motion, revealing that perspective is as crucial as propulsion. Even so, the scale is humbling. The Moon, Mars, and the outer planets are reachable with technology we already possess. The nearest stars require ingenuity beyond anything humanity has built. Neighboring galaxies are a challenge for civilizations yet to exist. The universe does not yield its distances easily. It is vast, indifferent, and eternal, a measure against which human ambition is both infinitesimal and extraordinary. Every journey across this cosmic ocean is measured not only in kilometers, but in patience, calculation, and courage. And yet, the scale of the universe teaches a deeper lesson than mere numbers. It shows us the relativity of ambition. Human lifetimes are fleeting. Civilizations rise and fall in millennia, barely a heartbeat against the rhythm of stars. Even if we could travel at near light speed, our journeys would span generations, leaving Earth far behind, stretching our understanding of time and endurance to its limits. The cosmos is not hostile, but it is indifferent. It does not hurry, it does not wait, and it reminds us that the distances we dream to cross are as much a test of the mind as of the machine. The scale of the universe also reframes the meaning of exploration. Traveling to Mars or Alpha Centauri is not just a matter of crossing kilometers or light years. It is a confrontation with the sublime, a recognition that our species is a small, fragile intelligence floating in a vast, silent sea. Each star we reach, each planet we touch, is both triumph and lesson. Proof that ambition matters, and that even against infinity, understanding and courage have weight. To journey at or near light speed is to travel through scales that dwarf human comprehension. Distances that seem insurmountable become manageable, yet remain overwhelming. The universe stretches in every direction, infinite in its mystery, eternal in its breadth. And in facing this scale, humanity is confronted with a paradox. The greater the distance, the greater the potential for wonder, insight, and transformation. Every cosmic mile, every light year traversed, is a measure not merely of motion, but of perspective. The universe is both larger than we can imagine and closer than we dare to dream. Light speed does not conquer distance. It transforms it, bending space and time into forms the mind can navigate. To look at the stars is to measure scale. To move among them is to experience scale, intimately and terrifyingly. And so, as we stand on the edge of our solar system, calculating trajectories to Mars, imagining journeys to Alpha Centauri, or dreaming of Andromeda, we are reminded that space is both a barrier and an invitation. It is immense beyond reckoning, yet malleable through motion. It is eternal, indifferent, and breathtaking. To travel at light speed is to step into this immensity, to confront the vastness not as a distance to be overcome, but as a reality to be understood, respected, and cherished. The scale of the universe is a challenge, a teacher, and a muse. It humbles, it inspires, and it pushes humanity to ask the questions that matter most. How far can we go? How much can we understand? And what does it mean to travel, not just across space, but through the very fabric of existence? For all the equations, all the star maps, all the propulsion technologies we might invent, there is one limit the universe does not negotiate: the human body. Space is a realm of extremes, a place where vacuum, radiation, and isolation conspire to remind us that life evolved for Earth, not the void between stars. To travel at near light speed is not only to confront the laws of physics, it is to confront the limits of flesh and mind against the infinity of the cosmos. Imagine leaving the safety of Earth, your vessel armored against debris and radiation, engines burning relentlessly to approach the unattainable. The stars rush past in streaks of light, time dilates, distances contract. And yet, inside that ship, a human heart beats no faster than it ever did. Lungs draw in recycled air, muscles atrophy, bones weaken. The body does not bend to the rules of relativity. It remains stubbornly terrestrial, a fragile organism trying to survive in an environment it was never meant to endure. Microgravity alone presents a relentless challenge. Astronauts on the International Space Station experience bone loss, muscle atrophy, fluid shifts, and vision changes, all over months, confined to a few hundred kilometers above Earth. Now imagine traveling for years at near light speed, where the journey to a nearby star, though compressed for the traveler, still strains physiology. Without constant exercise, without sophisticated artificial gravity, the human body begins to betray its host. Bones weaken, muscles waste. The mind falters as the sensory cues that anchor us to Earth vanish into the monotony of confined space. Radiation adds another unforgiving layer. The protective cocoon of Earth's magnetic field and atmosphere shields life from cosmic rays, solar flares, and high-energy particles. Beyond that shield, the universe becomes a stream of invisible bullets. At near light speeds, even a single dust grain becomes a projectile capable of annihilation. High-energy cosmic radiation pierces tissue, damages DNA, and threatens life at its most fundamental level. Shielding is possible, but it adds mass that requires more energy to accelerate, more fuel, and more risk. The universe punishes those who underestimate it. Isolation, too, is a silent adversary. Human beings are social creatures, evolved for connection and community. A crew separated from Earth, traveling decades across interstellar space, faces a psychological gauntlet few are prepared to endure. Loneliness, monotony, stress, and the profound awareness of distance from home can corrode mental health. Depression, anxiety, and interpersonal conflict are not theoretical. They are inevitable without careful preparation. And yet, unlike bones or engines, there is no simple technological fix. The mind is as fragile as the body, and just as vital to survival. Even perception itself bends under the strain of near light speed travel. Stars ahead appear blue-shifted, radiation from the cosmic microwave background intensifies, and the familiar constellations warp into strange, unrecognizable shapes. The universe transforms from a static, navigable map into a dynamic, disorienting torrent of light and energy. For the human brain, evolved to interpret the slow, steady rhythms of Earth, this sensory onslaught is both awe-inspiring and destabilizing. To survive the journey is to adapt not only physically, but perceptually, to rewire the mind to comprehend the alien realities of relativistic motion. And yet, humanity has shown resilience against extremes before. Sailors once crossed oceans with nothing but wind and wood. Pioneers traversed deserts, mountains, and tundras, testing the limits of flesh against environment. Astronauts ventured into orbit, then to the moon, facing dangers that would have seemed insurmountable to their ancestors. The same spirit of endurance, ingenuity, and adaptation will be required for interstellar travel. We must not only build ships, but cultivate bodies, minds, and societies capable of enduring decades, perhaps centuries, of motion through void. Sleep, nutrition, and social structure become as important as engines and shields. Habitats must simulate gravity, protect against radiation, and sustain human life with redundancy and resilience. Crew selection, training, and psychological support become as critical as propulsion systems. The human factor is not an afterthought, it is the central challenge. You can build a ship that approaches light speed, but if the flesh aboard cannot survive the journey, the mission fails before it begins. Relativistic travel also forces a reckoning with mortality. Even if time dilates, the crew faces the inevitability of aging, disease, and the passage of decades compressed by motion. Earth continues its orbit, generations are born and die, and the stars remain indifferent. The paradox is both sobering and profound. To reach the stars is to confront not only physics, but the fragility of life itself, to measure ambition against the delicate structures of flesh, mind, and society. Yet there is triumph in the human factor. The very act of preparing for these extremes transforms our species. We develop new medical technologies, advanced life support systems, and psychological strategies that not only enable travel, but enhance life on Earth. To face the infinite void is to understand the finite nature of life, and to adapt, endure, and thrive against it. The human factor is both limitation and opportunity, the bridge between aspiration and survival, between dream and reality. In the end, Flesh Against Infinity is a story of courage, adaptation, and ingenuity. It reminds us that interstellar travel is not merely an engineering problem, or a physics problem, or a technological problem. It is a human problem, a test of our resilience, creativity, and determination to survive where no life has ever existed before. The universe does not bend for us. We bend for it. We adapt. We endure. And in doing so, we discover that even the smallest, most fragile life can touch the vastness of stars. The human factor is the final frontier within the final frontier. It is a reminder that every journey through space begins not with a rocket or an engine, but with flesh, blood, and mind, daring to meet infinity. The stars await. But to reach them, humanity must first learn to endure itself. If the human body is the fragile vessel, propulsion is the heartbeat of interstellar ambition. To travel at near light speed, to bridge the chasm between stars, we must master motion itself. Yet even as we dream, the universe reminds us, fuel is finite, energy is precious, and every push forward carries a cost, measured not only in kilograms, but in the harsh arithmetic of physics. The rockets of today are magnificent, but they are children playing with fire compared to the ambitions of relativistic travel. Chemical rockets, the workhorses that carried astronauts to the moon, are limited by the energy stored in molecular bonds. They can accelerate a few tons of mass to orbital speeds, and perhaps a tiny fraction farther, but interstellar distances require orders of magnitude more. To propel even a modest ship to a significant fraction of the speed of light, we must look beyond chemical reactions to the very foundations of energy itself. Nuclear propulsion offers a glimpse of what is possible. Fission engines, harnessing the splitting of atomic nuclei, release energy millions of times greater than chemical rockets. Fusion, the process that powers stars, promises even more. An engine fueled by hydrogen isotopes could, in principle, accelerate a spacecraft to significant fractions of c. The physics is clear, the mathematics tantalizing, but the engineering is brutal. Containing a reaction of near-stellar temperatures, converting energy into thrust efficiently, protecting the crew from radiation. Every step is a wall of difficulty, a gauntlet of impossibility we must navigate to turn theory into reality. Yet even fusion is just a waypoint. To approach true light speed, we must consider concepts that today seem like science fiction. Antimatter engines, where matter collides with antimatter to release energy with perfect efficiency. Photon sails, pushed not by fuel, but by the pressure of light from lasers or stars. And, in the realm of speculative physics, warp drives, which would bend space itself to carry a ship faster than light without breaking relativity. Each of these ideas carries promise, but each also carries profound challenges, engineering hurdles, energy demands, and dangers that defy imagination. Consider antimatter. A gram of antimatter annihilating with matter releases the energy of tens of thousands of tons of TNT. Harnessing even milligrams safely would surpass humanity's total current energy production. Storing antimatter without letting it touch ordinary matter, without catastrophic explosion, is a task that has haunted physicists for decades. Yet, it is one of the few paths that, even in principle, could propel a ship to a meaningful fraction of light speed within a human lifetime. The power is staggering, the risks monumental, and the engineering unforgiving. Photon sails offer a different kind of elegance. Light itself becomes the propellant. A massive sail, thin and reflective, could be pushed by lasers from Earth or sunlight from stars. There is no fuel to carry, only a sail and the patience to accelerate over decades. At first, the push is imperceptible, but over time, velocity builds. Acceleration is gentle, continuous, and relentless, like the slow shaping of a glacier. The dream is simple. Light itself moves the ship, connecting energy and motion in a way the universe cannot resist. Yet the distances are immense, the technology delicate, and the precision required is almost absurd. A deviation of a millimeter over thousands of kilometers could send the ship drifting into eternal darkness. Warp drives, meanwhile, exist in the realm of speculation, though firmly grounded in the equations of general relativity. If we could contract space in front of a vessel and expand it behind, we could, in theory, move faster than light without violating local physics. Space itself would carry the ship, rather than the ship carrying itself through space. But the energy requirements are staggering, involving negative energy or exotic matter that may not even exist. To build such a drive is not merely an engineering problem, it is a challenge to our understanding of reality itself. Every propulsion dream shares a common truth. The closer we approach light speed, the harsher the universe becomes. Energy demands soar, collisions with interstellar dust and gas become catastrophic. Navigation grows delicate, requiring precision that defies human error. The laws of physics do not bend to ambition. They demand mastery, ingenuity, and respect. To move at these speeds is to confront the raw power of energy, momentum, and motion on a scale almost impossible to comprehend. And yet, it is precisely these challenges that inspire humanity. Rockets, fusion, antimatter, photon sails, warp drives, each represents a leap of imagination, a refusal to accept distance as an absolute barrier. Every engine conceived, tested, and dreamed pushes the boundary of possibility, transforming the dream of interstellar travel from fantasy into a potential future. Propulsion is not merely motion, it is hope given form. It is the physical manifestation of our desire to reach beyond, to touch stars, to leave the cradle of Earth behind. Without it, the cosmos is a gallery of unreachable wonders. With it, even fractions of light speed bring the nearest stars within a single human lifetime. Every acceleration, every push, every spark of ingenuity carries us farther into the universe, bending the laws of nature to the determination of human will. But the lesson remains: propulsion is only part of the equation. Even the most powerful engine cannot sustain life, cannot preserve sanity, cannot shield against time, isolation, or radiation. It is a tool, a bridge, a method to cross cosmic distances, but it is meaningless without the human factor. The flesh, the mind, and the society that gives the journey purpose. Rockets alone cannot colonize the stars. Humans must follow, endure, adapt, and survive. Propulsion dreams are the heartbeat of interstellar ambition. They remind us that the universe is vast, indifferent, and demanding, yet not unreachable. They force us to reckon with energy, mass, and momentum in ways that humble and exhilarate. They are the engines not just of motion, but of imagination, the proof that even in the face of infinite distances, human ingenuity can move, stretch, and challenge the very fabric of reality. And as the engines roar, whether fueled by fusion, photons, or speculative physics, one truth remains. The journey toward light speed is not merely about distance or speed. It is about ambition itself, about our refusal to accept limits, about the eternal human desire to reach beyond, to accelerate not just through space, but through possibility. To approach light speed is to confront the universe in its rawest, most unforgiving form. Space may seem serene, glittering with distant stars, but in reality, it is a battlefield of energy, matter, and radiation. The faster we move, the more the cosmos becomes a threat. A single speck of dust can become a weapon. Cosmic radiation becomes a relentless barrage, and the void itself offers no mercy. Traveling near light speed is not only a test of propulsion and endurance, it is a confrontation with danger on a scale our ancestors never imagined. Even the emptiest regions of interstellar space are filled with particles, hydrogen atoms, tiny dust grains, cosmic rays. At rest, they are harmless, almost undetectable. But at near light speed, physics transforms the trivial into the catastrophic. A grain of sand, just a fraction of a millimeter across, becomes a projectile with the kinetic energy of a high-explosive bomb. Dust and gas that would be inconsequential at slower velocities can pierce hulls, destroy electronics, and threaten life itself. Every centimeter of space becomes a potential danger zone. Radiation presents an even more insidious hazard. Cosmic rays, high-energy particles traveling near the speed of light, bombard spacecraft constantly. On Earth, our atmosphere and magnetic field shield us from this invisible storm. In deep space, there is no protection. At relativistic speeds, exposure increases dramatically. Not only does the ship's speed amplify collisions with particles, but time dilation transforms radiation into a relentless flood. DNA can break, cells mutate, and electronic systems falter. Radiation is not a slow threat, it is an omnipresent, invisible enemy, capable of dismantling humans and machines alike. The relativistic effect, known as blue shift, adds another layer of peril. As a ship accelerates toward light speed, the cosmic microwave background, the faint glow left over from the Big Bang, becomes increasingly energetic. What is harmless microwaves at rest transforms into dangerous X-rays and gamma rays in the frame of the ship. The very fabric of space ahead turns hostile, forcing the traveler to armor against threats that exist only because of motion. In other words, simply moving fast enough changes the environment itself into a weapon. The universe punishes speed with subtle cruelty. Collisions, radiation, and the void are not the only hazards. Navigation becomes a precision game of millimeters over millions of kilometers. Even a slight miscalculation can send a ship veering off course, colliding with invisible objects, or slipping into gravitational traps. Near stars or black holes, time and space curve, introducing forces that can stretch, crush, or destroy unshielded vessels. The cosmic ocean is not empty. It is alive with energy and movement. And the closer one approaches light speed, the more lethal its currents become. Then, there is the psychological hazard. Isolation, monotony, and the relentless awareness of danger weigh on the crew. Even perfectly engineered shields and autopilot systems cannot erase fear. Humans will spend years, perhaps decades, confined to tight quarters, knowing that outside the hull lies a universe capable of annihilation at any moment. The mind must endure alongside the body. Resilience is as vital as armor. Mental fortitude becomes a matter of life and death, just as essential as mass, velocity, and energy. Despite these hazards, humanity has a remarkable history of surviving extreme environments. Submariners face crushing pressure deep beneath oceans. Polar explorers endure deadly cold. Astronauts survive vacuum and radiation in low Earth orbit. Each represents a precedent. Challenges that once seemed unsurvivable can be met with ingenuity, preparation, and courage. The hazards of relativistic travel, while orders of magnitude greater, are extensions of these same principles. Proper shielding, redundancy, and psychological preparation can transform the lethal into the survivable. Engineers have proposed a range of defenses. Whipple shields, a series of thin layers designed to fragment incoming particles before they reach critical systems, can protect against micrometeoroids. Magnetic or plasma fields can deflect charged cosmic rays. Redundant systems, autonomous repair drones, and deep storage of essential supplies can mitigate catastrophic failures. Yet all these protections require energy, space, and mass, resources that are already stretched thin at near-light speeds. Every solution introduces new challenges. And still, the hazards are inseparable from ambition. To move faster, to reach stars within human lifetimes, is to accept danger as a constant companion. Every collision avoided, every gamma ray deflected, every navigational error corrected is a victory against the indifference of the universe. The cosmos is neither hostile nor friendly. It is impartial, and survival depends entirely on preparation, foresight, and adaptation. The relativistic hazards teach a lesson broader than physics. They are a metaphor for every human endeavor into the unknown. The closer we approach our goals, the greater the risks, and the more demanding the discipline required. The void does not bend to desire. Radiation does not negotiate. Dust does not forgive mistakes. To journey at near-light speed is to engage in a dialogue with the universe where every action has consequence, and only resilience, ingenuity, and courage allow passage. In the end, relativistic hazards are a crucible. They filter ambition, revealing what is possible and what is folly. They remind us that while dreams of the stars are intoxicating, they are inseparable from danger. Space is beautiful, but it is also deadly. To survive, humanity must respect its rules, anticipate its perils, and design not just machines, but systems, physical, biological, and psychological, capable of enduring what no human has yet faced. To travel near light speed is not merely a technical challenge. It is a confrontation with the universe in its purest form, empty, indifferent, and infinitely vast. Every journey through this void is a test of ingenuity, courage, and endurance. And for those who succeed, the reward is unparalleled. A glimpse of the cosmos as few have ever experienced. A triumph of life over the unforgiving. A testament to human daring against infinity. As humanity approaches light speed, we encounter one of the universe's most astonishing and counterintuitive phenomena. Time itself begins to bend. It is not imagination, nor fiction, but a consequence of Einstein's theory of relativity. For the traveler hurtling toward the stars, time slows relative to the world left behind. A journey that feels like years to the crew may span decades, centuries, or even millennia for those who remain on Earth. Traveling near light speed is, in essence, a journey into the future. This effect is called time dilation. It emerges from the way the universe binds space and time together. At everyday speeds, time appears absolute, flowing evenly for everyone. But as velocity approaches the cosmic speed limit, the flow of time diverges. Every second on the ship stretches into many seconds outside it. The faster the journey, the greater the dilation. The closer we come to light speed, the more pronounced the effect. A human lifetime on a near light speed voyage could pass in what feels like mere months to the travelers, while decades or centuries elapse on Earth. Imagine a spacecraft accelerating toward Alpha Centauri, 4 light years away. To those of us on Earth, the journey might take 4 years at light speed, a figure already daunting in human terms. But for the travelers, the effect of time dilation compresses that journey into a far shorter span. The stars streak past, distances shrink in the frame of the ship, and the crew ages more slowly than the world they left behind. They arrive at their destination, not exhausted by decades of travel, but almost unchanged, while Earth has moved inexorably forward. They have not just crossed space, they have leapt into the future. The implications of this are staggering. Consider a human leaving Earth in 2100 on a near light-speed voyage to a distant star. Even if the journey takes what feels like a few decades for the crew, centuries may pass on Earth. The civilization they left behind could be unrecognizable. Languages may evolve, borders may vanish, technology may transform, and entire cultures could rise and fall. The traveler is effectively cast into a future they cannot control, a visitor from the past arriving in a world that has continued without them. Time dilation also reframes our understanding of aging, mortality, and human ambition. Life aboard a relativistic ship is measured not in Earth years, but in subjective experience. Parents may depart, children may be born and die on a planet left behind, yet the traveler remains young. Generations pass outside while only a few pass within. The human perception of life, history, and connection stretches and strains against the relentless forward march of cosmic time. It is both a blessing and a curse, survival without decay, but separation without reprieve. There is also a profound strategic dimension. Time dilation becomes a tool for interstellar exploration. Ships could travel to distant stars, return to Earth, and deliver information or technology far into the future of civilization. Humanity could, in principle, send emissaries not merely across space, but across decades and centuries, accelerating the spread of knowledge. But this is not without cost. The travelers themselves risk alienation, disconnection, and the psychological burden of witnessing a world evolve without them. Even the mathematics of time dilation is poetic in its precision. If a ship travels at 90% of light speed, time aboard slows by more than half compared to Earth. At 99% of light speed, time slows almost tenfold, and as velocity nears 99.9999% of c, seconds on the ship become centuries outside. The universe itself seems to yield to motion, reshaping the flow of reality for those willing to take the risk. In a sense, the faster we move, the more we escape the tyranny of ordinary time. Yet there is an existential tension in this power. Time dilation allows humanity to survive long journeys, to explore distant stars, and to extend the effective reach of a single lifetime. But it also isolates the traveler from the familiar, from family, from the continuity of society. The universe may bend time for motion, but it does not bend emotion, memory, or human connection. The traveler becomes a paradox, alive, youthful, and moving forward, yet temporally unmoored from the world they left behind. Time dilation is not merely a physical effect, it is a meditation on perspective. It asks us to consider the relativity of existence, the elasticity of experience, and the intertwined nature of space and time. Traveling near light speed transforms not just distance, but the very meaning of life's duration. To journey to the stars is to confront the universe's clock, to negotiate with the relentless flow of time, and to emerge into a future shaped as much by motion as by circumstance. In the end, time dilation is both gift and challenge. It allows humanity to reach farther than ever before, to survive journeys that would otherwise be impossible, and to glimpse the stars on timescales our ancestors could not imagine. But it also demands sacrifice, courage, and acceptance of the profound isolation that comes from moving through time at a speed the world cannot match. To travel at near light speed is to travel not only through space, but through the very river of time itself, a journey that transforms traveler and universe alike. As humanity reaches for the stars, another barrier emerges, as invisible and unyielding as the void itself: communication. Space is vast, and the speed of light, our fastest messenger, imposes a tyranny over connection. To send a signal across interstellar distances is to confront silence, delay, and the profound isolation that comes from knowing that even the simplest message takes years, decades, or centuries to arrive. Traveling at near light speed magnifies this challenge, turning the universe itself into a medium of both wonder and frustration. Imagine a spacecraft en route to Proxima Centauri, 4 light-years away. A message sent from Earth will arrive only after 4 years. A reply will take another 4. To converse across this distance is to engage in dialogue with staggering patience. By the time an answer returns, the world may have changed, humans may have aged, and the context of the original message may be lost. Communication is no longer instantaneous. It is a slow, deliberate exchange across the canvas of time and space. Now imagine a journey to a star system 100 light-years away. Messages take a century to traverse each way. A single question could span multiple human lifetimes before a response is received. For travelers venturing to distant galaxies, communication becomes almost irrelevant, a whisper in an eternity of silence. The cosmos is not hostile, it simply enforces a scale that human social structures are ill-equipped to manage. Isolation becomes absolute, and the very act of sending a signal is an acknowledgement of our vulnerability to time and distance. This limitation has profound consequences for exploration and civilization. Ships cannot rely on constant guidance from Earth. Decisions must be made autonomously. Systems must be self-repairing. Knowledge must be carried within the crew, stored in machines, and safeguarded against failure. Humanity cannot remotely pilot a vessel across the stars. It must entrust the journey to those on board, or to artificial intelligence capable of learning, adapting, and surviving in the unforgiving silence of space. The speed of light also imposes a kind of cosmic perspective on events. A civilization observing a distant star sees it not as it is now, but as it was decades, centuries, or millennia ago. The universe is a record of its own past, and to communicate across it is to interact with echoes. When humans reach distant worlds, the societies, stars, and planets they encounter may be fundamentally different from the earthbound knowledge used to chart them. Every signal is a message from history, delayed, filtered, and refracted by the vast distances of space. Furthermore, communication becomes a matter of energy and precision. Signals weaken as they spread, fading into the background radiation of the cosmos. Powerful transmitters, massive antennas, and precise alignment are required to send even a simple message. Any error, any misalignment, and words vanish into the void, lost for eternity. Unlike the immediacy of terrestrial communication, interstellar messaging is painstaking, unforgiving, and easily disrupted. Silence is the default, and sound is the exception. This isolation carries psychological weight. The awareness that messages will be delayed, that no immediate response is possible, heightens the sense of solitude. Crew members may live entire lives knowing that Earth will never hear from them in real time, and they will never receive urgent instructions from home. The universe enforces patience, humility, and a self-reliance that stretches human endurance to its limits. Communication is no longer a bridge. It is a thread, stretched across centuries, fragile and tenuous. Yet there is beauty in this silence. The cosmos teaches us to rely on ourselves, to carry knowledge, wisdom, and purpose without constant validation. Messages, when received, become treasures, echoes of distant minds across unimaginable distances. The slow cadence of communication transforms ordinary interaction into reflection, deliberation, and care. To send a message to the stars is to commit to patience, persistence, and faith in the future, knowing that the universe rewards neither haste nor impatience. Time dilation, combined with communication delays, introduces paradoxes and challenges for civilizations. A traveler moving near light speed may experience decades while centuries pass on Earth. By the time a message returns, the context may have shifted, history may have advanced, and the universe itself may have moved beyond the comprehension of those left behind. Communication is no longer a simple exchange. It is a negotiation with the fabric of reality itself, a dance between time, distance, and understanding. In this cosmic silence, humanity learns humility. The stars are not just distant, they are isolated, separated by unyielding scales that demand ingenuity and patience. Every transmission, every signal, is a testament to endurance, a proof of existence across the gulf of space. We are creatures of connection, yet the universe teaches that connection is precious precisely because it is rare, delayed, and fragile. Ultimately, the silence of the cosmos is both challenge and teacher. It reminds us that distance is real, that time is relative, and that survival depends on foresight, autonomy, and resilience. To communicate across light years is to acknowledge our fragility, to confront isolation, and to celebrate the triumph of persistence over silence. The universe is not empty, it is patient, and for those willing to listen, to wait, and to endure, even the faintest echo carries meaning, guidance, and hope. At the edge of light-speed travel, at the boundary where physics, engineering, and imagination converge, humanity confronts the vastest question of all. What is our place in the cosmos? Every calculation, every engine, every hazard navigated is not merely a technical endeavor, it is a philosophical one. To traverse the stars, to approach the speed of light, is to grapple with scale, time, and the fragility of existence itself. The horizon of possibility stretches before us, both inspiring and humbling, and the journey is as much inward as it is outward. From Earth, the universe appears infinite, a tapestry of stars, galaxies, and nebulae. But approaching light speed transforms perception. Distances shrink, light bends, time dilates, and familiar constellations warp into streaks of unrecognizable brilliance. The cosmos, once a distant panorama, becomes a corridor of motion and energy, both beautiful and perilous. Each star approached is a reminder that the universe is not waiting for us. It is indifferent, vast, and demanding. And yet, in this indifference lies the ultimate challenge and the ultimate reward, the chance to reach further, to know more, and to test the limits of human ambition. Humanity's place in this expanse is simultaneously tiny and profound. We are, by any cosmic measure, infinitesimal, a species of fragile flesh and fleeting consciousness on a pale blue dot. Yet we have conceived of travel to the stars, imagined engines that bend energy, and confronted dangers that would destroy any other known species. Our fragility is matched by ingenuity, our limits by creativity, and our mortality by courage. To approach light speed is to assert existence in a universe that neither acknowledges nor grants it freely. The horizon of possibility also demands reflection on risk and reward. Near light speed travel is not a promise of immediate conquest or colonization. It is a gamble, a series of calculated bets against nature itself. Hazards loom in every particle, every ray of radiation, and every moment of isolation. Time dilation warps our understanding of generations, and communication delays stretch our connection to civilization to its breaking point. To venture outward is to embrace uncertainty, to measure hope against danger, and to carry the responsibility of every action across the void. Yet the potential is staggering. Relativistic travel transforms ambition into achievement, allowing humanity to reach stars within a single lifetime, to glimpse the distant past of the universe, and to witness futures otherwise unreachable. Civilizations left behind will age and evolve, but explorers moving near light speed carry forward knowledge, experience, and perspective that can reshape destiny. Each journey becomes not just a traversal of space, but a bridge across time, a testament to the human drive to understand, endure, and expand. Philosophically, near light speed travel reframes our understanding of life itself. The universe operates on scales far beyond ordinary comprehension. Distances measured in light years, energies measured in the kinetic force of near light speed collisions, and time measured in subjective versus objective frames, all remind us that reality is not fixed. To move at relativistic speeds is to engage with the universe on its own terms, to perceive its laws directly, and to recognize the delicate balance between ambition and vulnerability. there is also a profound moral dimension. If we reach the stars, we carry with us the responsibility of survival, of stewardship, and of continuity. Every crew, every civilization that ventures beyond Earth must consider the implications of their presence, the sustainability of life, the preservation of knowledge, and the ethical consequences of interacting with potential new worlds. The horizon of possibility is not merely technical, it is ethical, social, and existential. The stars are not a playground, they are a domain that tests every aspect of what it means to be human. And yet, for all the dangers and responsibilities, the call of the horizon is irresistible. Humans are explorers by nature, dreamers by necessity, and survivors by evolution. To stand on the edge of light-speed travel is to confront infinity itself and to recognize that our potential is as vast as the cosmos. Every challenge, collisions, radiation, time dilation, isolation, is also an opportunity to innovate, to endure, and to transcend the limitations of the present. Ultimately, the horizon of possibility is a mirror. It reflects both the universe's enormity and humanity's determination. It asks the question, how far can we reach, not just with engines and rockets, but with courage, creativity, and resilience? The answer is not yet written. The stars wait, patient, indifferent, eternal. Humanity stands ready, fragile yet determined, on the threshold of the impossible. Traveling at light speed is more than a technological challenge. It is a declaration that we will not be confined to our planet, to our moment in time, or to the limitations of our biology. It is a statement of curiosity, courage, and ambition. The cosmos is vast, our resources finite, and the dangers real. Yet, the horizon of possibility remains open. For those willing to endure, to innovate, and to dream, the stars are not merely points of light. They are destinations, teachers, and companions on a journey that defines what it means to be human. And so, as we look to the future, as engines hum and stars beckon, one truth becomes clear. The universe is infinite, our journey is uncertain, and our potential is boundless. Humanity's place among the stars is not guaranteed. It must be earned through vision, courage, and endurance. The horizon is ahead, shimmering, unreachable, yet tangible. And the first step into the void may be the most important step we ever take.